Hello, my name is Hyunjin. I am a student taking a Professor Bosa Park's lecture of Applied Physical Chemistry 1 in Seongkyungan University. Today I'm going to talk about one interesting natural phenomenon with a thermodynamic view. Now I will proceed with PPT. As you already know, there are many exciting physical, chemical, and biological changes in nature which can be understood on a basis of thermodynamics. Among them, what I'm presenting today is related to a phenomenon that many people can easily notice in their daily lives. Every morning, I stop by the cafe on my way to work and take out the hot Americano. After I get to the working place in about 15 minutes, hot coffee already become colder than before. Moreover, as time goes by, the coffee gets colder and I can no longer feel the warmth. As you all know intuitively, this is obvious phenomenon that hot coffee gives out heat to the surroundings and in turn the coffee cools down. So, how is this obvious? Have you ever thought about it from the perspective of entropy? Now, I'm going to prove this daily life phenomenon mathematically. As shown in the figures, the following two scenarios are possible. First case is that heat is absorbed by hot coffee and coffee becomes hotter as time goes by. Second case is that heat is released by hot coffee and therefore coffee becomes colder as time goes by. We already know scenario 2 is correct, but let's prove this mathematically. And let's say the temperature of the surroundings and the coffee are 25 degrees Celsius and 45 degrees Celsius respectively. Scenario 1. 10 joule of heat is absorbed from surroundings by coffee. So, surroundings lose 10 joule and the coffee gains 10 joule. Thus, heat of system is plus 10 joule and heat of surroundings is minus 10 joule. We know that the total entropy change is the sum of entropy change of system and entropy change of surroundings. Also, the entropy change is equal to heat divided by temperature. Therefore, we can write the equation like this. By substituting a number for each variable and calculating, we can achieve the following results. The sign of entropy change of universe is negative. This violates the second law of thermodynamics because entropy change of universe should be greater than zero. Therefore, the above process cannot occur spontaneously. Then, let's take a look at scenario 2. 10 joule of heat is released to the surroundings by hot coffee. So, surroundings gain 10 joule and coffee loses 10 joule. Thus, heat of system is minus 10 joule and heat of surroundings is plus 10 joule. Just like what I showed you earlier, by substituting a number for each variable and calculating, we can achieve the following results. The sign of entropy change of universe is positive. This obeys the second law of thermodynamics and therefore the above process occurs spontaneously. Today, through the above calculations, we have proved the daily life phenomenon that hot coffee gives out heat to the surroundings and in turn the coffee cools down occurs spontaneously. This very obvious phenomenon is governed by entropy. Like this, calculating entropy change for a particular reaction becomes important because we cannot predict if it will take place spontaneously or not just by looking at the chemical reaction. This is end of my presentation and this video. Thanks for listening.